So, how did you first get started with XCOR?
Well, I went to school in engineering at the University of Wisconsin in Madison, and that was right around the time that Spaceship One was beginning to do its X Prize flights. And so around that time, I started to get very interested in the whole new space movement, private space flight, low-cost space flight, really space flight outside of the realm of NASA, which was not something that I had understood existed before. And as part of that, I was following Spaceship One online, and I started looking for similar companies. And in particular, I started looking for companies where I could do a summer internship. So I found a few different companies online and ended up sending an email to XCOR. Got a response from Miss Alita Jackson, and came out for an interview and ended up getting hired as an intern. So I came on as an intern, worked for about 6 months. Enjoyed it. Fortunately, they wanted to have me back, and so I finished up school, and I've been full-time at XCOR since.
Awesome. So what can you tell us about the current progress of the Lynx spacecraft and other projects that XCOR is doing?
XCOR is working on two main projects right now. One is a continuing contract with United Launch Alliance, or ULA, in which we're working to develop a low-cost upper stage engine running on liquid oxygen, liquid hydrogen, which will make around 20 to 30,000 pounds of thrust. So over the past year, we've been focused on building up our cryogenic pumping capability. We've built and we've been testing a significantly larger cryogenic piston pump than we've done in the past. And we've also been upgrading our own facilities at Mojave to support liquid hydrogen testing. So we've been building a new engine test stand, which will be capable of using LH2. We've also installed a 1,500-gallon liquid hydrogen dewar, so we'll be able to do all of our hydrogen tests on site at XCOR rather than going off-site as we have in the past.
Now, would this engine be replacing the RL-10 for the Centaur stage, or would it be a completely new upper stage?
I don't know the details of how ULA plans to use it, and I'm not going to try and speculate on it. It's like I said, it's an engine that's suitable for use as an upper stage engine. But beyond that, how they plan to use it is entirely up to them.
Okay. So what's the other main project you're working on?
So the other main project that XCOR is working on right now is Lynx. And that's where most of our engineering effort has gone in the past year. Lynx is a suborbital spaceplane. It's a rocket aircraft powered exclusively by its own rocket engines. Basically, it gets towed out to the end of a runway at Mojave or any other spaceport where it could operate, and lights its rocket engines. It'll have 4 engines burning oxygen and kerosene. It'll make about 11,000 pounds of thrust. And when it lights its engines fully full of propellant, it'll be a thrust-to-weight ratio of about 1 to 1. So it'll really move down the runway in quite a hurry. It'll accelerate down the runway, take off, and essentially pull up and head directly for space. Lynx is going to be able to reach about Mach 4, and peak altitude will be about 100 kilometers. So it'll be able to take 1 pilot and 1 spaceflight participant just past the edge of space. Once it gets there, you'll be in 0G for a few minutes. You'll pull a few Gs during reentry, and then you'll sort of glide back down to an unpowered landing back at the airport you left from. So the whole flight's about 20 to 25 minutes, but in that 20 to 25 minutes, you have 3 minutes of weightlessness, you have 3 minutes of rocket-powered boost that ends at about a 3 to 1 thrust-to-weight ratio. You have a fairly exciting re-entry pullout, and you also have a fantastic view. You're going to be able to see 500 miles in any direction from the spaceport that you're flying out of. So it should be pretty spectacular.
Can you explain to us the difference between the Lynx Mark 1, 2, and 3?
Mm-hmm. Just as a side note, I'm not sure that the Mark 3, I don't know how well we've defined the Mark 3 publicly, so I think I'll just speak to Mark 1 and Mark 2 for today. Okay. So the first version of Lynx that we're building is called Lynx Mark 1, and that's essentially the prototype version of Lynx. It's that vehicle is being designed to reach a slightly lower altitude and a lower top airspeed compared to our follow-on production version. Mark 1 is going to be able to reach about 60 kilometers, or roughly 200,000 feet, and it'll be able to go Mach 2. So we're still talking about an airplane that's, faster than almost every modern airplane, and reaches an altitude that nobody has reached without rockets. But because we have lower performance targets, it's easier on the designers at XCOR from several perspectives. First, we don't have to be as concerned about the weight of our components. for the first version of Lynx that we build, which makes it easier to design, and also hopefully will make our ultimate production version higher performance. Basically, the idea is we can build components with extra margin for Lynx Mark 1, and we can find out during the flight test program how much of that margin we need. So we'll have quite a bit more guidance when we go back and redesign those components for Mark 2 as to where our margins actually are and how much weight we can save. The other thing is that because Mark 1 doesn't fly as quickly, it won't be exposed to as high a heating environment. Things won't get as hot during the flight or during reentry. And because of that, we can use a different set of materials which are easier to work with. The materials are also a little bit easier to modify, so we can do tweaks to the airframe shape during the flight test program. Eventually what we intend to do is we'll start with a certain airframe which we've gotten from wind tunnel tests. We'll fly that. We'll probably make a few tweaks here and there during flight test, but we expect that the Mark II airframe will be identical from the outside to the Mark I airframe. They're both being designed with the same aerodynamics, so they'll look very similar from the outside. The only changes will be sort of structural and propellant changes on the interior of that vehicle. So Mark I, bottom line, 200,000 feet Mach 2. Mark II will be able to get up to 100 kilometers, or about 330,000 feet, and that'll reach Mach 4 during its reentry phase.